8 bits and these are 8 bits. Bits can hold only two values, either 0 or 1. Bits can hold only two values. It can either be 0 or it can be 1. So if it is all 0, it is 0.0.0.0. And if it is all 1, then it is 255.255.255.255. How did we arrive at this number 255? Understand this part very clearly here. It's not because 2 to the power of 8. The calculation is, since these are 8 bits, so you calculate from 2 to the power of 7 plus 2 to the power of 6 plus 2 to the power of 5 plus 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, up to 2 to the power of 0. Up to 2 to the power of 0. If you add this value, you will get 128 plus 64 plus 32 plus 16 plus 8, 4, 2, 1. And sum of this is 255. It is not because of 2 to the power of 8. Because if you follow that logic, then your decimal to binary conversion will go wrong. Then your decimal to binary conversion will go wrong. Are we all clear? Everyone? Sure, I will have this document shared. Don't worry, Eram. I'll have this document shared. I'll have it uploaded in the LMS. Okay. So, further, let's understand. For example, if I want to write binary, of 192.168.2.1, then how do I write it? So basically, if I have to convert this IP address in a binary format, then all I have to ensure is follow this map. What combination of this bits will make 192? So if I keep this bit on and this bit on, sum of 128 plus 64 will make 192. So I kept these two bits on here and remaining bits are 0. What combination of this will give me 168? So this bit on, 0, on, 0, on. So if you add this up, it will be 168, remaining bits are off. What combination of this will give me 2? So this bit should be on, rest of the all bits are off. What combination of this will give me 1? Only this last bit should be on, remaining bits can be off. Are we clear on how to write binary of your decimal numbers, everyone? Yes? Can I have quick confirmation? Are we all clear? Awesome. So I want you to quickly help me with an binary for this number. Please help me with binary for this number. 225.129.10.3. Everyone? You have 1 minute. Quickly perform the binary calculation for this decimal number. Convert this decimal to binary. I showed you how to do that. Please follow the same method and help me with the binary. Are we done? Everyone, are we done? This is the correct answer. Please check. Couple of people. Please check. 225.129.10.3. This is how you convert into binary format. So to get 225, 128 plus 64 plus 32, which will make 224 plus 1, 225. So this 4 bits can be off. So that's what is the game here. 129, the first bit and the last bit should be on, remaining bits can turn off. 129. 10, 8 plus 2 will make it 10. Remaining bits can be off. So this is 8 and this is 2. 3. So last 2 bit will be on. Remaining can be off. Am I making sense? Are we all clear? How do you convert your decimal to binary, everyone? Awesome. So now let's move a bit forward. If we are all clear, let's move a bit forward and let's talk about the next aspect. Okay, let's understand. Give me 1 second. Let's understand one part. Why do we write this /8 /12 /16 /29 /24 and all of this? Why do we write these numbers after our IP addresses? These are nothing but your subnet mask. These are nothing but your subnet mask. /8 /12 /16 /24 /29 /32. All these numbers indicates what? Subnet mask. Now in class A, you can go up to /8. In class B, you can go up to /12. In class C, you can go up to /16. Not below that, right? So what does this signify? This signifies how many number of usable IP addresses you can have in that range. How many number of usable IP addresses you can have in that range. Now when I say 10.0.0.0/8, what does it signify is the first 8 bits are fixed. First 8 bits are fixed, remaining bits can change. So that is why if you notice the range 10.00/8, it starts from 10.0.0.0 and ends with 10.255.255.255. So 10 here and here towards the start and the end, the 10 is fixed, but the remaining values, it changes from 0 to 255, 0 to 255, 0 to 255, right? So when I say /8, that means my first 8 bits are fixed, remaining bits can change, right? So how do you write this? Understand very clearly. So 10.0.0.0 goes up to 10.255.255.255. So the very first usable IP address would be 10.0.0.1 goes up to 10.0.0.255, like 10.0.0.1.2.3.4.5 up to .255. Then it will change to 10.0.0.10.0.10. Okay, 10.0.10, 1.1, 1.2, 1.3, 1.4, like this up to 255. Then 10.0.2.0, same sequence up to 10.0.2.255. Same sequence till 3 dot something. And this will continue until it reaches 10.255.255.254. This IP address 10.0.0.0 is called your network address. Okay. And this is called as broadcast address. This cannot be used. This are reserved in your network. For every subnet, you have the first IP is called as network address and the last address is called as broadcast address. Are we all clear? Everyone? What does this /8/16/12 all of this signify is number of usable IP addresses you can have. Number of usable IP address you can have. So remember, your first address is your network address and your last address would be your broadcast address. And you cannot use this address. If it is a bigger range, then accordingly the last address. If it is smaller range also, then the last address in that range. All right. And how do I know total number of usable IP address? So the logic is very simple. The formula to derive total number of usable IP address is 2 to the power of total number of bits minus subnet mask. So 8 was the subnet mask. So 2 to the power of 32 minus 8 minus 2. Minus 2 is broadcast address and network address. So you remove these two addresses. So 2 to the power of 24 minus 2. If it is /16, 2 to the power of 32 minus 16 minus 2. So 2 power 16 minus 2. It will not be like 16 minus 2, 14. It will be whatever value I get for 2 to the power of 16 minus 2. So it is something like this. Are we all clear how to calculate total number of usable IP addresses? Everyone? So here I have given a calculation for 2 to the power of 24/24. So you see 2 to the power of 32 total number of bits minus 24 and minus 2. So 2 to the power of 8, it becomes 32 minus 24 is 8. So 2 to the power of 8 minus 2. So 256 minus 2 and total number of usable IP address you have is 254. Are we all clear with this? Everyone, I would appreciate if you can quickly respond. What is the confusion on /24 part? I said this is the range 192.168 1.0/24. So what did I say here? Total number of bits minus number of fixed bits. So 24 is the fixed bit. So 32 minus 24. So 2 to the power of 8. So 2 to the power of 8 is 256 minus 2. So total number of usable IP addresses is 254. Any confusions, Nimai? Okay, now help me understand. If it is instead of 24, let's make it 29. Can you tell me number of usable IP addresses I can have? Everyone, can you guys quickly tell me what is the total number of usable IP addresses I can have? Yes. It is 6 IP addresses. Agree with me? The total number of usable IP addresses which we can have is 6. Clear everyone how to calculate the total number of usable IP addresses? Awesome. So now let's move a bit forward in that case. Now let's move a bit forward. So we talked about the fundamental of IP addresses and everything. So I want to ask you one question. Let's assume that I am an organization xyz.com. I have 50,000 employees working in my organization. 50,000 employees working in my organization. Now all these 50,000 employees wants to connect to internet. So how many public IP addresses should I have? Think well and then answer. I have 50,000 employees working in my organization. All the 50,000 employees wants to connect to internet. Because remember, private IP addresses are not routable over internet. So how many public IP addresses should I have? So a couple of people are telling 50,000, couple of people are telling 1. So I want to understand those who say 1. How do you feel with having just one public IP address? All my 50,000 employees will be connected to internet, will be able to connect to internet. Exactly. So total number of public IP address needed would be somewhere around 3. Somewhere around 3 public IP address would be needed. Okay. So that ensure that all my 50,000 users are seamlessly able to connect and use internet. Right? Like you can also achieve using one IP address. I agree to that point, but it would not be seamless. So let's understand how. So let's assume that these are my machines with a private IP address. Let's say 10.10.10.1, and this is .2, and this is your 10.10.3. Okay, and let's assume this is the gateway address 10.10.10.10, right? And this gateway has a private public IP address of 1.1.1. Let's say this is your internet, and let's assume this is the server on internet which you want to access. Okay, let's assume the IP address for a moment, google.com's IP address for a moment 2.2.2. Let's assume that. So now ideally what happens, we understand that your private IP addresses are not routable over internet. Okay, we understand your private IP addresses are not routable over internet. So what does it signify is, if you have a private IP address, your machine cannot connect to anything on internet. Now in this scenario, I cannot procure 50,000 public IP addresses, right? So what we do is we use the concept of NAT and PAT. We use the concept of network address we use the concept of network address translation, or along with this we use the concept of PAT. What is PAT? Port address translation. Okay, so these are the two concepts which we use. One is your network address translation, another one is your port address translation, right? So you don't have to procure 50,000 public IP addresses. Now how it works, all this machine which wants to connect to internet, whenever they want to reach or whenever they want to connect something on internet, they will forward the traffic towards the gateway. They'll forward the traffic towards gateway. Gateway could be your router, your switch, your firewall, right? So on this gateway, it will have two arms. One will have your private IP address, another one will have your public IP address. So it will understand that this machine wants to connect to internet. So, but this machine has only private IP address. So it will check, do I have NAT rule configured? Okay, if I have NAT and PAT rule configured, it will translate this private IP addresses, each of these private IP addresses with public IP address and forward this traffic towards internet. Forward this traffic towards internet. This is what we call it as network address translation. Are we all clear? So as an organization with 50,000 employees, even if you have 2 to 3 public IP address, you should be good to go. Because with one public IP address, at one point of time, concurrent sessions are limited. So you can have maximum of 65,535 concurrent session. So when I say 65,535 is concurrent session, because those are the number of ports. Beyond this, your traffic will start to drop. So what do I mean by that? Let's say if I'm a user one, if I'm opening 2-3 tabs, I say on one tab, I say google.com, facebook.com, youtube.com. So as an individual user, I have consumed 3 ports from that. As an individual user, I consumed how many ports? Out of the 65,000, if I open 3 tabs on my machine, so I have consumed 3 ports. So out of 65,000, I have consumed 3 ports. So imagine we have 50,000 users. Assuming each user bare minimum uses one, bare minimum opens 2 tabs. So how many concurrent sessions would we require? 1 lakh concurrent session. So having one IP address would not be sufficient. Are we clear? We should bare minimum have 2 to 3 IP addresses. Everyone, are we clear how it works? Why there could be network jam? I did not understand when you say network jam. What do you mean by that? When all thousands of employees are accessing internet, okay. You mean the congestion? It will be routed to 3 IP addresses. It will not be routed to 3 IP addresses. It will be routed to your gateway. Understand there is a difference between routing to those specific IP addresses and routing to your gateway. Here the gateway will do translation. The IP addresses are not doing the translation. So gateway will have enough capability to perform these translations. The performance will be taken care by the gateway device. Are we clear? Everyone? So that's the concept of network address translation. One more part and then we will start with the networking on AWS. Okay. Now, is the NAT only for outgoing traffic? No. In our on-premises, we also use NAT for incoming traffic as well. From internet, if someone wants to connect to your resources, then also you can use NAT. That is called as destination NAT. So NAT has multiple types. You have source NAT, destination NAT, static NAT, dynamic NAT. There are multiple types of NAT possible. Okay. So even for your incoming traffic also, that is possible. What is PAT then? Changing the port numbers of your traffic. So as I was telling, you can use how many? 65,000 port numbers. So here it wants to change it to, it wants to send the traffic to port 80. So the source port number from this machine is, let's assume 1234. Okay. Now, while it reaches 1.1.1, obviously the IP address is changed, that is network address translation. It will also change the port number when it is forwarding towards internet. This is called as PAT. This is called as PAT. So this port number is changed and this IP address is changed. When IP address changes, it is NAT. When port number changes, it is PAT. So when the reverse traffic comes back, when the return traffic comes back, from this port, it will give it to in this indeed will send it to this IP address. So this translation of port or changing of port is what we call it as PAT. Clear? Am I making sense? Okay, cool. So one thing which I want to quickly check with all of you guys now, in case, okay, now in case if this machine wants to communicate with this machine, or let's say if this machine wants to communicate to this machine, will the traffic go to gateway and then come back, or it will be directly forwarded? Let's be quick to answer. Will it go towards gateway and then come back like something like this in a U shape? It goes to gateway, goes to internet, from internet comes in. This is the direction, or direct. It's a direct. Okay, awesome. So many people are saying it's a direct connectivity. Super. Now let me ask you one question. How does this machine know that if I want to forward the traffic to this range of IP address, forward it directly and don't forward it to gateway? How does this machine know that if this is the IP address range, right, then forward it to gateway, and if this is the range, then directly forward it here? Using subnet mask. Not only this, very true. It is because of the subnet mask. But if I want to make it more granular answer, then I would say it is because of the destination address. Agree with me? It is because of the destination IP address. Yes. Now this machine will have something called as route entry. Something like this. It will have something called as route table, and in route table there would be a route entry, in which it will be determined that if you want to go to this destination IP address, then forward towards gateway. Rest of the IP address, keep it on network. Something like this is defined. Yes. In your route table, you define this detail that, hey, if you want to go to internet, forward it towards gateway. If you want to, access any other IP address, then it is on link. On link is nothing but within our network. Do not forward this traffic to gateway. So it uses the concept of route table to determine which traffic it has to forward towards gateway and which traffic it does not have to forward towards gateway. Are we all clear with this, everyone? On the same page? Net mask is nothing but wildcard mask. Like on the basis of subnet mask, you write it net mask. So this represents /24. This represents /24. Only the last octet can be changed. So it says these are all fixed. The last octet can change. It is subnet mask. Okay. So with this, we complete the fundamentals of route networking. I hope you all understood now what networking is. Those who said you're from a non-networking background, I hope each and everyone have a fair enough understanding about networking. Yes, everyone. Those who said you are completely new to networking, can I have your quick responses? Are we all good? Do we have fair enough understanding about the subject now? Obviously, it would not be 100%. You need to practice. You need to read a few materials on internet. Okay, but a fair enough understanding is what you should have by now, right? So now let's move a bit forward. Let's talk about networking on AWS. So networking on AWS is kind of similar to what we have in our on-premises. In our on-premises, do we have different environments like prod environment, dev environment, QA environment, and so on? Yes or no? In our on-premises, do we have this different environment, prod, dev, QA, and so on? Yes, right. Now, what is the purpose of this different environment? Why do we have these different environments? We do testing in QA. Okay. So without creating QA environment, we cannot do testing, is it? Now, without creating a QA environment, I cannot do any kind of testing. They can't do in prod. Okay, let me reserve some 10 machine. In overall infrastructure, let me put some 10 machine and say that all testing needs to be done on this 10 machines only. Is that not possible? Because this is something we use day in, day out. These terms, hey, prod environment, dev environment, QA environment. But 95% of people in the industry don't know what is the purpose of having these environments. Why do we create this environment? The question is that QA needs to do load testing. So that's what I'm telling. Let's have 10 machines completely reserved, and let us say that all testing, all development, everything we'll do on this 10 machine. Why can't we do that? Why can't we have one infrastructure and do all testing? Okay, these are a list of 10 reserved machine. All testing needs to be done here and not on any other machine. Why to create different environment and make things, difficult? Did you all understand the question? Prod should have separate priority. to simulate prod in terms of configuration. So again, people are talking the same terms. So when you say prod should have separate priority, so let's say there are 30-40 machines on which my prod applications are running. So I can keep them on high priority list. For that, why should I create different environment? My question is that simple. What if load increases? So by having segregation, load will not increase. Load can increase even when you have this separate environment, right? Load can definitely increase even when we have separate environment. Am I making sense? So let me tell you, all this is not done because you want to, if you have high load, then production will be able to manage it. What is production? We have named it production. These are only machines. Do we have different data centers for prod, dev, QA, and all of that? No, right? Do we have different data centers for each of these environments? For prod, you have one data center. For QA, you have different data center. For dev, you have different data centers. Obviously, no. Agree with me on this? It's all in the same data center, correct? Your prod machine is also sitting in the same data center. Your dev machine is also sitting in the same data center. Your QA machine is also sitting in the same data center, right? So this is nothing but your logical segregation of your infrastructure on the basis of IP address. It is logical segregation of your infrastructure on the basis of IP address. Two people have answered my question. Okay, I did not read out, their answers loud because I wanted others to, try. So one of the answer was for easy management. One of the answer was easy management of your resources in an infrastructure. And the other person said security. So the reason why we have this environments created is because we want to make our management easier. Okay, management of resources should be done easily. Second, security. Now, how from a security, please understand very clearly. Even the ease of management comes the second. Okay, but security is the first part which we can achieve by having this logical isolation. Now understand, how do I say this? Let's assume you have one environment, no logical segregation like prod, dev, QA, and all of that. Okay. If one of your machine is compromised, let's say there is some malware got injected in one of your machine, right? So can I say if it is one single network, that malware can get replicated in all your resources within your infrastructure? Yes or no? If malware is injected to one of your machine in the network, you have one single network, no logical segregation. For prod, you don't have separate IP. For QA, you don't have separate IP. Everything is one single network. Let's say if there is any cyber attack, then can I say there is no way you can control this spread? Agree with me on this? One of machine is compromised, the malware can get replicated throughout the network and your entire infrastructure would be impacted. Now, if we have this segregation, let's say one of your prod machine is impacted. So can I say the impact area, or the impact surface is now reduced only to prod infrastructure, because it can replicate only within that logical network, not beyond it. Am I making sense? Everyone, why do we have this different environments created? So that
isolation is easier, management is easier, and accordingly the security norms can be applied. Like in your prod environment, you want to apply certain security norms, telling that, hey, no, from none of my prod server, I should be able to connect to internet. From prod server, that should not be an internet access. But you must have noticed at times from your dev server, you are able to access internet. So if you want to allow those distinct security norms and regulations, if you have one single network, you will not be able to achieve that. So that is why you break down into logical networks, so that you can allow or you can define relevant norms as per the business requirement. Are we all clear? Why do we have these environments today? So all this while, even if you are not aware, I hope now you have clarity on what is the purpose of having these environments created. Yes, everyone. Because it's not only you. I've seen a lot of people from industry, right? In spite of working in industry for 10 years, 15 years, they fail to answer this one simple question. When we ask them, hey, why do you think we have this segregation? There is no answers from them. They're like, sorry, I did not understand. That is the response. I've asked these questions in interview, to be very honest. I've asked people these questions in interview. Okay. When I go with third party consultants, right? So they sometimes seek our help to interview people. At that point of time, when asked, majority of people prove to be blank on this. So please remember, this is very, very important to understand. Why do we have, this kind of setup created? So now, if you want, when you move to cloud, you might still want to have this kind of segregation, right? Yes or no? When you want to move to cloud, would you not want this kind of setup? Like you should have prod environment, dev environment, QA environment, and so on. Obviously, yes, you would. Agree with me? So if you want to achieve this kind of requirement in your prod, then you should use the concept of VPC. You should use the concept of VPC. Because in your prod, using the VPC, in your cloud, sorry, not in your prod, in your cloud, using this concept of VPC, you can logically isolate your infrastructure. VPC stands for your virtual private cloud. It has nothing to do with your private cloud. Please understand private cloud deployment model. It is nothing but logical segregation of your infrastructure, like how in your on-premises you create your prod, dev, QA, and all of that. Here you're doing it by creating VPC. Are we all clear with this? Everyone, can I get started with the deployment of resources in AWS? VPC is not a term linked with the cloud. It is a term linked with your AWS cloud, virtual private cloud, but it has nothing to do with your private cloud deployment model. Remember, we talked about different types of deployment model: public cloud, private cloud, community cloud, and so on. It has nothing to do with it. So irrespective of what deployment model is, your VPC concept will still be applicable. So now let's get started with the deployment of it. But before that, let me show you this diagram which I was just drawing here in parallel. Okay, I had frozen my screen to draw and ensure that I have complete attention, right? So I'm going to create a VPC. Pay attention to this. Okay, I'm gonna create a VPC with the IP range 10.10.00/16. Within that VPC, I'm gonna create a server subnet, a DB subnet. In server subnet, I'll deploy a server machine. In DB subnet, I'll deploy an kind of DB machine. Okay, with server subnet, I'll have server route table. With DB machine, I'll have DB route table, and I'll have this as internet gateway created. Okay. So we are going to create this kind of environment right now. Anyone has any question? I'm going to create first a prod VPC. Within prod VPC, I'm going to create server subnet and DB subnet. And I'm going to create server route table, DB route table, and internet gateway, and associate with respective, subnets and VPC. And I'm going to launch a machine in each of these subnets. Are we clear with this diagram? Can I go ahead with the implementation of it? Everyone? Any questions before I start implementation? Clear, right? Awesome. Awesome. So now let's get started here. So I come back here. I say VPC, hit enter. Click on this VPC. So this is your default VPC. By default, when your AWS account is created, in every region, you'll have a default VPC. Okay. So your resources should be launched within a VPC. Now I'll say create VPC, give a name to it. So let's call this as prod VPC. IP address range 10.10.0.0/16. This is the range of my VPC. So create VPC. Now my VPC is created. Now my prod VPC is created. So within my prod VPC, I need to create subnets. So I click on subnets here. These are all subnets associated with my default VPC. I need to create a subnet for my prod VPC. So which VPC here? Prod VPC. So name of the subnet is what it is asking me for. So let's name this as server subnet. And which availability zone? I can define my own availability zone requirement. And this is my server subnet range, which is part of my master VPC range. So can I assign any other range here like 192.168.1.0/24? Will it accept? No, it will throw me an error. So it should be within the range. It should be range. It should be part of this bigger range. Am I making sense with this? Guys? So I create my subnet. So my server subnet is created. Next, I need to create one more subnet. That is my dev subnet. That is my dev subnet. So let's say create subnet. Again, part of my prod VPC. Name of the subnet is, DB subnet. Sorry, not dev. Yeah. I'm sorry. Say DB subnet. Okay. And here I'll say 10.10.2.0/24. Right. There we gave 1.0/24. Here I'm saying 2.0/24. So I have these two subnets also created, right? DB subnet and server subnet. And these are associated with my prod VPC. My DB subnet has range of 10.10.2.0/24. This has range of 10.10.1.0/24. Next, I need to create route table. So by default, when a VPC is created, a route table is created by default. Okay. So we'll use this route table. So we'll say it as DBRT. That is nothing but your DB route table. Now, since we are calling this as a DB route table, I'll have to click on subnet association, say edit subnet association, and I'll associate DB subnet with DB route table. I'll associate DB subnet with DB route table. Okay. Next, I'll create one more route table because we need one more route table for our server. Since we had this one created by default, we have repurposed it. Now I'll create a route table for my server. So I'll name this as server RT. I'll name this as server RT. Okay. Both should be in the same availability zone. No, it's not mandatory. You can have your server subnet in South 1A. You can have your DB subnet in South 1B. Even then it will work. Okay. So I create this server RT. Server RT, which VPC? Prod VPC, right? So I say create route table. So now my server route table is also created, but I need to associate server subnet with it. So again, the same thing, select that route table, say subnet association, say edit subnet, and say server subnet. So now I've created my route tables also. So I created VPC, then I created subnets, then I created route table. Next, click on internet gateway. Say create internet gateway. Create internet gateway. So name this as prod IGW and say create internet gateway. Attach this internet gateway to your VPC. Which VPC? Prod VPC. Done. Right? Done. Delete default route table. No, the default route table is with default VPC. It has nothing to do with your prod VPC. That is a separate environment. So no need to delete the default route table. Clear? This VPC is completely separate. So VPC created, subnet created, route table created, and created IGW and associated, right? So this job is done till here, correct? Now what is pending? We need to create one server machine. We need to create one DB machine, correct? If we create these two, then our entire diagram would be completed. So all the components in the diagram would be created. So I have duplicated this window, and here I'll say EC2. I'll say EC2. I'll say instances. Say launch instances. And I'm gonna launch a Windows machine. Okay. Say configure instance detail. Here it will ask me. Remember, I told you we will talk about network when we come to our module 7. So this is what I wanted to highlight. So here it will ask, in which environment do you want to launch this machine in? So right now I want to launch in prod. So I say prod VPC. So under prod, is this machine part of your server subnet or DB subnet? You can have multiple subnet, right? So I'm saying a part of server subnet. Do you want public IP address? I say enable. I want public IP address, right? And remember one important thing which I want to update you of. In your on-premises, I gave you this formula. Remember 2 to the power of, where is that? This formula, 2 to the power of total number of bits minus the subnet mask minus 2, I told you. But when you go to cloud, it would be minus 5. Remember this. In your cloud, it would be minus 5. All right. Because 2 IP addresses which we use for broadcast network, that is there. Along with that, we need to assign 2 more IP addresses for, virtual broadcast and network address, and 1 IP address for AWS. So earlier we said 2 to the power of 3 minus 2 to the power minus 2. Here now it would be minus 1. So right now if you notice, I gave /24. So ideally in /24, how many usable IP address should I have? In /24, how many usable IP address should I be having? 254, correct? We should be having 254, 2 to the power of 8, which is 256 minus 2, and we should have 254 IP addresses, right? Agree with me, everyone? So ideally, we should be having 254 IP addresses. But now when we go to cloud, it is 251. Now if we go with cloud, it is 251. Okay. Now why it is 251? Because here we use -5. Why -5? Because see, why -5? Understand very clearly. The two IP addresses are reserved for your network and broadcast. Okay. And 3 IP addresses are reserved for virtual network address and virtual broadcast address. And one is reserved for AWS physical host. See, in your on-premises, everything is physical. So you just reserve 2 IP addresses for network and broadcast and you're good. But when you go with cloud, you have to reserve for virtual network and virtual broadcast address and one for the physical host. That is why -5. Are we clear? Everyone? Yes? So now let's move a bit forward. So this is why we have 251 usable IP address here. So I say next add storage, next security group. Okay. Okay. Launch. So this is my server machine which is getting launched. Okay. I have public IP address also associated. So I say launch instance. So I say launch instance. So this is my server. And here if you notice, is the IP address from the subnet range? Yes or no? The IP address which we have received 10.10.1.228. So is that from the my server subnet range? The range of my server subnet was 10.10.1.0/24. So /24 means the first 24 bits are fixed. The last bit can change. So obviously in the last octet we have this number. So this is my server machine. So let's name this as server. Okay. So I'll create one more machine in my DB subnet. So I'll say launch instance, Windows Server. Here again, I'll select my prod VPC, DB subnet this time. And I don't want public IP address with my DB machine. So I say disable. So last time the private IP address was automatically assigned. Now if I want to manually assign, then this is how I can add. Let's say I want this IP address specifically, right? I want to statically bind this IP address. So I can define instead of auto assigning. Okay. So that's where I should define it. And here I select the security group. I say launch. And here I go about it. So my DB machine is also getting ready. So I'll name this as DB. And here you notice the IP address, is that the one which I defined? 10.10.2.33 from the subnet range of my DB machine, right? Are we all clear? Everyone? So is this diagram completed? Creation of resources as per this diagram, is that clear to all of you? We created a VPC. Within VPC, we created subnets. Then we associated route tables with those subnets. We created IGW, Internet Gateway, and we associate that with VPC. And we created machines in the in the subnets. Anyone has any question? Any questions? So now let's start with our use case discussion one by one. Okay. let's start with our use case discussion one by one. So use case 1, 2 and 3. We are gonna discuss 3 different use cases, 1, 2 and 3. Okay. So let's say my use case 1 here. So the requirement number 1 is from internet, any user, let's assume this is user machine 1. Okay, user 1. So from internet, my user should be able to connect to my server. From internet, my user should be able to connect to server. Okay, and from server, my machine should be able to connect to internet. Did you all understand the requirement? If I am a user over the internet, I should be able to I should be able to take RDP of this server machine. So that is like user is able to connect to this machine over the internet. And from internet, I should be able to access google.com, Facebook. From the server, I should be able to access google.com, facebook.com, youtube.com and all of that. Are we clear? Everyone? From internet, I should be able to access my machine. And from machine, I should be able to access internet. Bidirectional communication with internet should be possible in a very layman language. So for this, what configuration is needed is what we are going to see. So right now when we created this route tables, we created this server. Does your server know if it has to go to internet, where should it forward the traffic? Does your server machine know that if it has to go to internet, where should it send the traffic towards? Yes or no? Obviously no, because the route table, let's see, this is my server route table. If I see the routes, I will understand. It knows to go where? Only to this destination range. Anything apart from that, it will not understand how to handle the traffic. Agree with me? It says what? If the destination is 10.10.0.0/16, target is local. Anything apart from this, your server does not know the route. So what configuration should I make? I need to add a route. Now what route should I be adding? Everyone, any thoughts around it? Any thoughts around it? So can I say if you want to go to anything on internet 0.0.0.0, then what should be the target? If you want to go to internet, what should be the target? Where should it forward the traffic? Towards IGW. Agree with me? Towards the internet gateway. So I'll say towards internet gateway, and I'll save these changes. Now this is done. Let's come back here. Let's access our server then. Copy the public IP address. Say remote desktop connectivity. Say connect. It will ask credential. Let's get ready with the credential parts. And let's connect. Let's connect. So this is my prod server. This is my prod server machine. So from internet, I'm able to connect to my machine, right? Because if I'm able to take RDP, then can I say it signifies that from internet user is able to connect to this machine? Agree with me? Now let us check from server, do we have internet connectivity or not? So I open this Internet Explorer. I say google.com. So I am able to connect to internet from my machine. So are we all clear with the first use case? Yes or no? Bidirectional communication is available. So to make this enable, what we defined is, we defined a route entry in the server route table. To enable this bidirectional communication, we have defined a route entry in the server route table. If you don't define this, neither you will be able to connect, nor from server you will have internet connectivity. Clear with this, everyone? Great. So now let's move a bit forward. Let us discuss the second use case. Now the second use case is, from this machine, I should be able to connect to this machine. From my server, I should be able to connect to DB. So for this, what kind of configuration do I need? From my server, I should be able to connect to my DB machine. So what kind of configuration do I need to make? Everyone, let's be quick to respond. Guys, no responses from anyone. Did you understand the requirement firstly? The requirement is, from this machine, I should be able to connect to this machine. So we need to define routing in server route table. Okay. Let us say this is my server route table. So you say I need to add a route entry. Tell me please, what route entry should I add? So I have one route entry telling 10.10.00/16 target is local. Another route entry is 0.0.0/0 target is IGW. Now DB server address. Okay. Others? DB server address. Is it? Everyone agrees that I should add DB server address here. And what should be the target then? What should be the target? IGW? No? Okay. Then target please. What should be the target? Subnet mask. How do you define that subnet mask? There is no provision that you can add any subnet mask in the target field. Target should be local. Okay. But let me ask you once again, is it mandatory that I should define a DB server address here now? Looking at the current configuration, Do you think there is a need that I should define a DB server address? Does your DB server does not fall under this range? Is your DB server address not part of this bigger range? Is it or not? It is, right? Then when it is already a part of bigger range, then do we still need to configure? Obviously no, right? Agree with me? Okay. So do we need to make any configuration on DB route table? Why no? Because from server, let's say HTTP request is coming here. The HTTP response also should come here, right? Yes or no? From server, if HTTP request is coming from this machine to this machine, the response also has to come back here. Or let's say this is a DB query generated by your application. So response to that DB query has to be given. So if there is no routing, will your DB machine be able to send traffic towards your server back? No, it will not be able to. So we need to ensure we have a return route. So there should be a route entry in DB as well. Agree with me? Without that route entry, your return traffic will not work and connectivity will not get established. Clear? Why? Because your route tables are stateless. When I say stateless, what do I mean? If point A to B, you know the route, it does not mean that B to A is also known. It has to be explicitly defined. Your route tables are stateless. Always remember this. Just because you have traffic coming from A to B, it does not mean from B to A you will be able to send the traffic back. So DB route table, routes. So here when you created route table, by default this route was there. So do I still need to define anything? But in case if this route was not there, then would I had a need to define? Let's assume if this route was not there, then can I say it would ask me to define a route? Only then the connectivity will work. Agree? So yes, it is mandatory. But right now in our case, we don't need it because the route entry is already there. Clear? So now this is my DB machine. Let's copy this private IP address. From my server, I say remote desktop connectivity. From my server, I'm saying remote desktop connectivity. I say the IP address and say connect. It will prompt me for password. So let's see the IP addresses here. So we have connected to our DB machine from our server. Yes. So we have connected to our DB machine from our server, right? So the second use case, are we all clear? So second use case, are we all clear, everyone? Now the third use case. Now the third use case, understand very clearly. The third use case is my user from internet. Pay attention. My user from internet should not be allowed to connect to my DB machine. If any user who is trying to connect to this DB machine over the internet, that should not be allowed. But however, from my DB machine, if someone wants to access internet, it should be allowed. So from DB machine towards the internet, outgoing connection, that is nothing but from my DB machine, I should be able to connect to internet. But from internet, no one should be able to connect to DB machine. Are we clear with the requirement part? Everyone? Are we all clear? What is the requirement here? From internet, no one should be able to connect to my DB. But from my DB, if I want to reach to Microsoft website to get the patches, or if I want to reach to the Oracle website to get patches and all of that, I should be allowed. So now let us first verify the part A. From internet, if I try taking access of this machine, remote desktop connectivity, and let us check if I'm able to access. Will it connect? What do you think? Will it connect? Yes, no? Don't wait for the results on the screen. Okay, those who say no, can you tell me why? Because we are not able to connect, that is very sure. But those who say no, can you tell me why? There is no route for 0.0.0. Is it? Is that the reason? Security is not defined. What security you want to define? Already there is a security group associated, which allows traffic from everywhere on the internet. So now, answering this question, if I add a route here to 0.0.0, is that the requirement and will it work? Is that the requirement? Will it work now? Guys? Okay, it will work, right? So many people are telling. So let me add. Now, when I have added this, let's come back here. Let's say connect. It will still not work. It will still not work. Can someone tell me why? I got one or two answers correctly. It will still not work. The users from internet will still not be able to connect. Let's be quick. Tell me why. No IP defined. So IP is already defined. Here it is the IP address. 10.10.233. That is the IP address. Remember one thing. Yesterday I told you, and today morning also I started my session with that word. I mean that line. Private IP addresses are not routable over internet. Do you recall this? Private IP addresses are not routable over internet. So right now the address which we are trying to connect is what? The address to which we are trying to connect is what address? It's a private IP address. In case of our server, we were able to connect because we had public IP address. Am I making sense, guys? Why we are not able to connect? So this machine has only private IP address, and hence we are not able to connect. So can I say the part A of the requirement is already fulfilled without I having to do any additional configuration? Agree with me on this? The part A of the requirement is already fulfilled. Now this private IP address, which is acting as a blessing and not allowing users from internet to connect, the same private IP address becomes a showstopper when this machine wants to connect to internet. Agree with me on this? The same private IP address will become a showstopper if I want to connect from my DB machine towards internet. Yes? Yes or no? So now from my DB machine, if I want to connect to internet, okay, why Vivek says no? So Vivek, you mean we'll be able to connect to internet? Okay, through internet gateway. Again, the same doubt. All right. So right now I'm into DB route table. Let's add a route entry again. I deleted it. I thought, it's no more needed. So if I add this internet gateway, I'll be able to connect. Is that the understanding? So I added a route entry now. Okay, 0.0.0 forwarded towards internet gateway. How many of you say that now I'll be able to connect to internet? How many of you guys say that now I'll be able to connect to internet? Okay, couple of folks. So let me tell you, you'll not be able to connect. Let me tell you, you'll not be able to connect. Why? The logic is very simple. Your private IP addresses are not routable over internet. Request timed out. You notice this, which basically signifies there is no internet connectivity. Won't it be netted at IGW? No. Here, remember I told you while configuring IGW also, there is no IP address that I'm associating. Just created IGW and attached it to VPC. It does not have any intelligence. So we need to do NATing. We need to do NATing. And for us to perform NATing, we need to go ahead and create a NAT gateway. So we need to introduce a new element in this diagram. Okay. And what is this new element? We need to have something called as NAT gateway. Guys, did you all understand why we were not able to connect? So we need to introduce something called as NAT gateway. So from your route table, you should forward it towards NAT gateway. And from here, it will go to server route table and it will connect to your IGW. Clear? So I'm going to introduce a, NAT gateway now. So on the same page, here I have NAT gateway. Click on that. Say create NAT gateway. Say create NAT gateway. Give a name. So let's call it as prod NAT gateway. Select subnet. Okay. Selected it. Say allocate elastic IP address. This will come with the cost. Now, what is the difference between elastic IP address and public IP address? That is a bigger question. So understand one thing, in your AWS, the public IP address which you have associated with your server is different from an elastic IP address. So this public IP address is from the AWS pool. Okay. So when you stop your machine and start your machine again, right? This IP address can change. It is dynamic. It is not a fixed IP address. But when I say elastic IP address, understand very clearly, it is a fixed IP address. So here AWS will charge you for providing elastic IP address. They will not charge you for providing this public IP address, because they're like, it's okay. You can change whenever you want. I mean, we can change this IP address whenever we want. It is not a fixed IP address assigned to you. But elastic IP address is a fixed IP address. Are we clear? And now my NAT gateway is created. Now help me understand. Is there any other additional configuration that I should be making? Now that NAT gateway is created, any other additional configuration needed? Let's be quick. Yes, what configuration? What configuration needed? Tell me, please. We need to perform routing. Very true. We need to perform routing. So come to your DB route table, say edit route. So if you want to go to internet, should I forward towards internet gateway or NAT gateway? What is your thought? On my DB machine, what I should say, if you want to go to internet, forward the traffic towards NAT gateway. Agree with me? Save changes. So now let's come back here. Do you see the pings are getting successful now? You notice this? So can I say from my server, I'm able to connect to internet? Google.com pages, from my DB, I'm able to connect to internet. For server, it is towards IGW. For DB, why it is NAT gateway? Because your server has a public IP address, so that can directly go to internet gateway and traffic is routable over internet. But in your DB, you have only what? Private IP address. So private IP addresses are not routable over internet. So you first forward it towards NAT gateway, where the translation will take place. Your private IP address will convert or will be translated to public IP address and will be forwarded towards your internet. Are we all clear? Okay, someone says, okay, Vivek says, can you show me the configuration for NAT gateway? Here it is. Here is the configuration for your NAT gateway. Any questions? Where do you route IGW in NAT gateway? Very interesting question. So I'm not sure if you guys paid attention to my configuration of NAT gateway. While configuring NAT gateway, pay attention here. While configuring NAT gateway, which subnet did I select here? Here I was supposed to select a subnet. Which subnet did I select here? We selected server subnet. Yes or no? We selected server subnet. Do you all agree? While configuring NAT gateway, I had selected server subnet here. So which means what? My NAT gateway is part of which subnet? My NAT gateway is part of server subnet. Agree? My NAT gateway is part of server subnet, correct? Without any doubt. So for my server subnet, do I already have a route table entry telling that if you want to go to internet, forward the traffic towards IGW? Yes, there is already a route entry. So I don't need to explicitly define to my NAT gateway that this is how you forward it to internet gateway. So NAT gateway, actually, if I had to draw this diagram here clearly, I did not want to confuse you at that point of time. So actually your NAT gateway is part of this server subnet. So by default, what happens from your DB, the traffic is forwarded to your NAT gateway. Your NAT gateway will use this route table and forward it towards internet. This is the actual representation of the diagram. Are we clear now? So we discussed three different use cases. Pay attention. From internet, how to connect, bidirectional connectivity, unidirectional connectivity, and within the network connectivity, right? Within the VPC connectivity, sorry. Are we all clear with it? Anyone has any questions, doubts, queries before I move forward with the next part of discussion? Any confusions? Was the networking concept interesting so far? I want to specifically check with those folks who said that they are coming from a non-networking background. Did you find it easy to understand? Yes. Now, okay, interesting but little confusing with a lot of information. Obviously, I mean, see, in one single go, you will not be able to grab. You will need to practice. But if you understand the concept, you'll be able to, you'll be able to easily go ahead and practice this. Can you please repeat server and DB bidirectional connectivity? So, which part here? You mean from my server, I'm accessing DB. Is that what you're referring to? So, from my server to DB connectivity, can I say it is within the network? Yes or no? It is within my network. So what I need to ensure is in my server, there should be a route towards this DB, and in my DB, there should be a route towards this server. In my server route table, there should be a route towards DB subnet, and in my DB, it should be a route towards my server subnet. So here in our case, what happened is by default, in both the route table, we have a route towards the bigger range 10.10.00/16. Okay, and target is local. So this range is for your overall VPC. So when you have this range, you don't need to explicitly configure it because your server subnet, your DB subnet, can I say it's part of this range? Agree with me? So that is what we meant here. Are we clear? Cool. So now let's move a bit ahead. Let's talk about one small part before we call it a day. Okay, because we have few more information coming in. Okay. So before we call it a day, let's do one thing. Let us discuss one more part of it. Okay. So let's assume that I have one more VPC. Let us say this was my prod environment. I have my dev environment. Let's assume this. Okay. In my dev environment, I have a subnet, and in that subnet, I have a machine. Okay. And let's say my dev environment range is, I said dev VPC here. Let's say I have 172.1.31.0.0/16. This is the range of my dev VPC. And some subnet range also something like this, 172.31.x.x/something. Let's assume 24. Okay. So the requirement in this case is this machine in my dev VPC should be able to connect to this machine in my prod VPC. See, my prod environment machine and my dev environment machine should be able to talk to each other. So ideally, we have this kind of requirement even in our on-premise infrastructure. Agree with me? Yes or no? We have this kind of requirement coming in our on-premise infrastructure also. So we can expect similar kind of requirement coming in our cloud environment as well. So firstly, let me understand from all of you guys. So should this traffic go via your internet gateway? Should this kind of traffic between your VPCs, should it go via your internet gateway? What is everyone's thought on this? Yes, no? Obviously, no. Obviously, this kind of traffic, which is within your AWS infrastructure, it is like, let's say you have a server in your data center prod environment and you have another server in your dev environment in the same data center. Will you want the traffic to go to internet and then come back into your environment? Say ideally both the servers are sitting in the same data centers, right? So would you want the traffic to go to internet and come back, take a U-turn and come back? No, right? So it is within the network. So within your infrastructure, within AWS environment, basically, not even within network, let me say, within AWS infrastructure. So if you have this kind of requirement in cloud, we have a concept called as VPC peering. So right now, let me show you, I have two VPCs. One is my prod VPC, another one is default VPC. So both have different range, right? Different range of IP address. So can I say I already have two VPCs? Yes. Agree with me, I already have two VPCs. So let's say I'm creating a machine here in my, default VPC this time. So in the default VPC, I am disabling public IP address. And I'm launching this machine in my default VPC. So it will have IP address in the range of 172 something. Okay, 172.31 something. So this is a machine which is launched in my default VPC. Now, if this machine wants to talk to my DB machine, which has an IP address of 10.10.2.33, then for that, what I need to do is I need to establish peering connection. I need to establish something called as peering connection. So to establish peering connection, please be informed. To establish peering connection, you need to click on this peering connection, say create peering connection, give a name to this peering connection. Let's say prod to dev connectivity. Who is requesting for this connectivity? Let me say My prod VPC is requesting. Prod VPC is interested to establish this connectivity. The another VPC with which you want to establish this kind of connectivity is this in your AWS environment or some another AWS account. If another AWS account, select that and say account number. If it is account, your account, say your account, my account only. Same region or different region. The other VPC with which you want to establish peering, is that in the same same region or different region? Right now, in my case, it is a same region. So I selected the other side VPC is this. Say create peering connection, and it says what? VPC peering connection has been requested. I say okay. I say okay. Right? VPC peering connection has been requested, and I say okay to that. So now if you notice here, it says pending acceptance. Since here I am the only requester and I am the responder, right? Both are me. So I can select this, say action, say accept request. In case if it is a different region or different account, then the other person has to do that. So now my peering connection is active. So help me understand, is there any other additional configuration that I am supposed to define? What other direction? So peering connection is bidirectional. If you establish one, it is okay. Any other configuration am I supposed to make? Let's be quick. Yes, no? Yeah, so requester and acceptor both can exchange information now. Okay, no other configuration. Everyone, no other configuration needed? Is it so? So let me ask you then, if you guys say no, let me ask you, does your DB machine know if it has to forward traffic towards 172, where should it send that traffic? Or does this machine know if it has to send traffic towards your DB machine in the prod environment, where should it forward that traffic? Don't you think we should make some routing configuration? Don't you think we need some routing configuration telling that from my DB machine, if you want to go to 172.31.00/16, then what should be the target? IGW? What should be the target here? Peering connection. Peering connection. Why NATing is needed? Why NATing is needed? We are not going to connect anything on internet. Peering connection. Agree? So I define this route entry in my DB route table. Because if this DB machine has to go forward the request there, it should know how the traffic should flow. Where should it go? So I have defined that it should send that traffic towards peering connection. Let's say this is your peering connection. So it knows that if I want to go to 172 something, then forward traffic towards DB route table, from DB route table towards the peering connection. So I'll be able to reach the other side. Now, can I say I should define the similar kind of requirement in the other side also? Yes. So in this route table also I should define. Agree with me? So I select the other side route table here. Okay. I say routes, edit routes. Now add route. Now what should be the destination address? Let's be quick. What should be the destination address here? Ten ten 0016. Agree with me? 10100016. Basically what you're telling, if you want to go to this destination address, forward traffic towards your peering connection. Clear everyone? Any confusions? So on my default routing table, I said, if you want to go to 10100016, forward traffic towards your peering connection. And in my DB route table, I told that if you want to go to 172 something, forward traffic towards your peering connection. Right? Clear? Everyone, can I have quick confirmation before I move forward? Cool. So now let us see. Now let us go back here and let us try to connect. So I copy this private IP address. So I take access of my machine. So this is my DB machine. So from my DB machine, I'll say remote desktop connectivity. Say connect. It will ask for credentials. Is the route entry correctly defined? Ah, my mistake. So it should be 1010, not 10. I had wrongly defined a route. So it was throwing me an error. Now it should connect. Instead of 1010, I said 10000. So it was throwing me an error. In VPC, one DB machine has DB machine is not accessible from outside via internet. So how we are accessing via VPC2? So if you notice how I have connected, pay attention. Take this diagram. I am an internet user. I connected to my server machine. From server machine, I took access of my DB machine. From my DB machine, I'm connecting my VPC2 machine. Manoj, I'm not directly connected this DB from internet, and neither I'm connecting directly to this machine in the other VPC. I've connected to my server machine. From server, I've taken access of this. From here, I'm taking access of the other machine. I hope I'm making clear. So this is my server. From my server, my DB, and from my DB, my dev machine, my dev VPC or default VPC machine. Are we all clear? Everyone? So with this, we complete our module 7. VPC has /16, why machine has /24? Okay, let me ask you this simple question in a way. Your overall house is constructed on 2000 square feet. So under 2000 square feet, do you construct your bedroom also? Your bedroom is obviously smaller, right? Yes or no? Let's say you have taken 2000 square feet of land area. So that means what, your prod environment as a range will be bigger. Within that, if I'm creating smaller subnets, for my server, I'll give one range. For my DB, I'll give one range. For my storage, I'll give one range. For my network, I'll give one range. So I need to create multiple logical units. Agree with me? Just like in our house, we create multiple smaller units. One bedroom, other hall, living area, kitchen, and all of that. We create smaller unit. So this larger unit is divided into multiple smaller logical units. The same concept goes here also. Manoj, making sense? So /16 is a bigger range, /24 is a smaller range. Everyone, are we clear? Any questions, doubts, queries? Do they charge for gateways? Absolutely yes. They will charge you for NAT gateways. Not for internet gateway, but your NAT gateways are chargeable. The elastic IP address associated is chargeable. So now if anyone has any question, then do let me know. If not, I think yes, we are done with our today's session. I hope you all enjoyed the session. I hope you all understood the networking concepts well. Can I send request from my server route table to my local premise servers? So that means over the internet connectivity is what you're referring to, Venkat. Correct? Yes, it is possible. You can have over the internet connectivity or through VPN connectivity. It is possible without any challenges. You should have appropriate route entries done. Does it clash default route table? Why will it clash with default route table? See, your VPC, default VPC has a separate range. Your prod VPC has a separate range. So route table cannot clash. Yeah, if you define, then yes, then it will create a clash. If you willingly define it in that way, then obviously it will clash, and that will lead to a network problem in your infrastructure. Any other question? Local forwarding, when you say, please elaborate. What do you mean by local forwarding? So DB route to server route table, which I showed you, no, how it can be done. So I showed you that only, right? I took connection. I took access of my server. From server, I took access of my DB. So that is your local forwarding. So instead of RDP, you can be using SSH, HTTP, any other protocols.
Is it kind of local forwarding within the environment traffic, that is? See, within the environment and outside the environment are two types in which you can forward your traffic. If it is within, we call it as local network traffic. If it is outside, then that would be like beyond your network. So it is possible. We saw both. What confusions? From our DB machine, we connected to internet. From our DB machine, we connected to our, default VPC machine. So both are possible, right? So protocol can be SSH, HTTP, any other protocol, that is absolutely okay. But if you have connectivity established, the connection will go through. If no, connection will fail. Clear? Cool. Any other question? PAT can be shown. No, by default, your NAT gateway will take care of the patting. We don't have to explicitly define anything. It is taken care by your NAT gateway itself. Only in terms of NAT instance, you'll be able to see that. Or when you have a dedicated firewall or router where you define this, there you will be able to see this. But on NAT gateway, you will not be able to see this. Clear? Any other question from anyone? Few people who is raising hand, just want to check. SR Guru, you have any question? What about firewalls? Will you cover that? No, Vivek. That is, outside the scope of this course, so we'll not be discussing. All right. If no further question from anyone, then I think, yes, we are done with our today's session. Okay. There is no subnet in AWS. You mean in the default VPC? Is that the question? So in default VPC, we have subnet. We have 3 subnets. 1, 2, 3. These are part of the default VPC only. Clear? Cool. So with this, I would like to call it a day. Thank you so much once again for all your time and patience. I really appreciate it. So I will see you all in the next week. Wish you all a great weekend ahead, and we'll continue further in the next week. Till then, bye-bye. Take care. Please go back, practice this. You'll be able to remember this concept very easily. go back, look into the class recording. That will also help. Okay. So thank you so much for all your time and patience. Really appreciate it. I wish you all a great weekend. Thank you guys. Signing off for the day.